Got it? So there you go, guys. So there you go. So is the voice clear, guys? Is the voice clear for everybody? Is there any disturbance? Just trying to bring the mic a little closer to me. Okay, thanks, Phil. So let's have a quick recap as to what we have discussed yesterday. I hope you're able to see. Oh, no. Okay. I hope you're able to see the screen now. Okay. So yeah, now. So can we go through as to what we have discussed yesterday quickly? Anybody in the class? Anything that you could remember? Okay. So we started discussing about the components of LoadRunner. Okay. We started discussing about the components of LoadRunner. Okay. What are the components of LoadRunner that we have discussed? VUgen. Okay. Which is virtual user generator. Okay. Virtual user generator. The second one is the controller. Okay. The actual execution happens in the controller with multiple users and with multiple scripts. Okay. So the controller actually controls what? It controls three things. It controls the scripts. Okay. It controls the LGs and it controls the virtual users. Okay. And the last one is the analysis part, wherein you do further analysis of the results. Okay, further analysis of the results. So these are the three components, but there is one component which is hiding, which runs as a background process, wherein you will not be able to see it. What is that? What is that fourth component? Wonderful. I'm glad somebody said Magnet Tech Pro. Okay, wonderful. It's LGs, and the process which runs behind the scenes for the LGs is magnetproc.exe. Okay, so for every application there is a process which runs behind the scenes. Yesterday we have seen it for Microsoft Word. Okay, there is a process which runs behind the scenes. Okay, maybe it's msword.exe or something like that. Okay, for Excel sheet there is a process which runs behind the scenes for every single application that you run. Maybe Skype, maybe Google Chrome. Okay, chrome.exe. For everything there is a process which runs behind the scenes. For VUgen, obviously there will be a process which runs behind the scenes. Controller, there will be a process which runs behind the scenes. Analysis, similarly LG as well. The process which runs behind the scenes for LG is magnetproc.com. Magnetproc.exe. Typically this process will be an executable file which is a .exe. If you have any doubts, you can go to this task manager and you can see what all the processes which are running behind the scenes for each of those applications. You see, for the HP LoadRunner agent process, it is magnetproc.exe. If you wanted to see what it is for Word, just open the Word and the process related to that will open. So you just looking at the description, you will be able to figure out where is this Word process is running. You see Microsoft Office Word. You see winword.exe. Winword.exe is a process which runs for the Microsoft Word. .exe means it's an executable file. Okay. So wonderful. So for everything you have an executable file. You see Acrobat, Adobe Reader, even though I haven't opened an Adobe Reader, an executable file which always runs behind the scenes. This is the reason why some of the people will not install Adobe Reader. Even though I didn't open anything related to Adobe or PDF, Adobe is related to PDF if you know it. Okay, there is a process which always runs behind the scenes, even though irrespective of the application is open or not. Same with Skype. You see, I didn't have any Skype open, but there is always this one open, Skype. Okay, executable file. Anyways, So this is what we have discussed, and we started talking about each component, why it is used, how we can do it, and all that. And we have studied and we have gone through a case study as well. We have gone through a case study as well. Okay, we have gone through a case study as well as to how the whole thing works. So let me go through that case study again. Okay, I have changed couple of things. Okay, so that it is clear to everybody. Okay. So let me open that case study. Okay, so the case study is a repetition, guys. The case study is a repetition. Please stay with me. Okay, if you think it's boring, yeah, I understand. But some of the people, you know, they didn't get the clarity yesterday about this case study. So quickly, I will go through the case study. I'll not spend too much time on the sample case study. Okay, but this is the repetition from yesterday, guys. This is the repetition from yesterday. Okay, let's quickly go through this case study, guys. Okay. Okay, let's quickly go through the case study. As a part of NFR collection, PT team has received following. Let's see what the PT team has received. What did it receive? 50 performance critical transactions or business process for the banking application. First of all, the application under test is a banking application, and as a part of NFR collection, which is the first stage, they've received a couple of NFRs. What is that? 50 performance critical transactions or business process. Second, the load test needs to be executed with 1000 concurrent users. This is what the PT team has received. Okay, so in the test planning phase, workload modeling is done, which gives the pacing and user load for each group. You know, in the controller, you know, each script that you upload will be a group. Now we have 50 scripts. Okay, now we have 50 scripts. There obviously there will be 50 groups. So you need to know with each group how many users needs to be assigned. So this workload modeling will give you that information for each group. How many users needs to be there. So the breakdown, in other words, the breakdown of the users as per the group will be done in the workload modeling sheet. And there is something called pacing. Which comes out of the workload modeling. So when we discuss about this workload modeling, we'll discuss more about this pacing. At this point of time, you just have to understand that this 1000 users needs to be broken into these 50 scripts. So that thing will be provided by my workload model. Okay. In the test design phase, PT team has created how many scripts? 50 scripts. Why? Because there are 50 performance critical transactions that you have collected as a part of NFR. So how we create the scripts? Using the component called VUsers. Okay. Now the PT team has executed each script separately to make sure they run without any issues. Okay, separately in the VUgen. This is what how they have done in the VUgen itself. They have executed separately just to make sure that there are no issues whatsoever. Okay, now this is an important thing. Now all the 50 scripts are put together in the controller. You see, all the 50 scripts are put together in the controller. So this is the controller. So they have put together all the scripts in the controller. And from the workload modeling, you know each group how many users you will get. So this account summary group, let's say as per the workload modeling, it is supposed to be assigned 200. So you will assign that. Statement history supposed to be assigned 100. So you will assign that. Where will you get this information? Account summary 200, statement history 100, balance transfer 250. Where will you get this information, guys? Where will you get this information from? No, you as per the NFR you got that you need to run with overall 1000. Okay, in the NFR you got that overall 1000 you need to run it. But I need this breakdown from account summary 200 users, statement history 100 users, balance transfer 250 users. Where will you get that breakdown from? Where will you get that? I want to hear the answer from everybody. Please participate, guys. For some of you, it might sound repetition, but I wanted to get this. Okay, wonderful. From the workload modeling sheet, from the WLM, you get this information. From the WLM, you get this information. Okay, so now you see 1000 users are broken down across all the groups as per the workload modeling. Now you execute the test in the controller. Okay, so you execute the test in the controller. So you hit on the run button. You hit on the run button. Now you tell me all these 50 scripts will be executed at once or one after another? Will be executed at once or one after another? Wonderful, Lashim. At once you execute all these scripts. At once these scripts will be executed simultaneously with all these users. Simultaneously with all these users will be executed at once. Okay, so now, once you execute it, obviously you will get the results. Once you execute it, any execution you will get the results. Okay, you execute, you get the results. You get the results. Results is the output of this execution. So this test that you are running, how long you run this test, guys? How long you run this test? How long you run this test? Can somebody please tell me? 1 hour. 1 hour. That's a standard time. 1 hour. Okay. You always remember that this test will be executed how many hours? 1 hour. 1 hour. Okay. So once you get the results, so one important thing that you get as a part of the results is response times. Right? The whole purpose. Always remember, guys. One of the very important purpose of doing performance testing is to capture the response times. Why capture the response times? To make sure if the application is fast or slow. This is the whole purpose of doing the performance testing, guys. Always remember, whether you have collected NFRs, whether you have done the planning, whether you have created the scripts, whether you have executed in the controller, what is the whole purpose of this performance testing life cycle or all these stages of the process? One important thing is to capture the response times. And where will you look at these response times? In the results. In the results. Okay. So once you execute this in the controller, you would have the results. So one important thing that you look as a part of the results is the response times. Okay. Now these results are compared against the SLS. These results, whatever the results that you get, is compared against the SLS. Where will you get this SLS, guys? Where will you get this SLS? Where will you get this SLS? From the client as a part of NFRs. From the clients as a part of NFRs, you will get this SLS. So now you go back to your NFR document. Now you go back to the NFR document. Let's say the NFR document says that. Okay. Let's assume your NFR says that. What is that? All the simple transactions, the response time should be less than or equal to 2 seconds. All the complexity level transactions, which is of level medium to medium, so the response time should be less than or equal to 5 seconds. And all the transactions which are complex, the response time should be less than or equal to 8 seconds. This is the NFRs that you said, that you got. Okay. Now you started comparing your results with the NFR. Okay. Let's watch this very carefully, guys. These are the transactions from your scripts. You see, these are the transactions from your scripts. Okay. All these transactions. Okay. And these are the SLS. You see, the complexity level, which is medium, the SLS is what? 2 seconds. Okay. So you see, what is the transaction? Buffer. Always remember the transactions will be named in this way. Okay. The project name, let's say this is a banking application and the project is Bank of America and the script is account summary and the transaction is T01 and this is a login transaction. Okay. So let's assume this is a simple transaction. This is a simple transaction. This is the SLA because SLS is what? For all the simple transactions, the SLS is 2 seconds. Yeah, it's 2 seconds. And what you have achieved is 1.2 seconds. Once you have executed this test, you have achieved, as per your results, is 1.2 seconds. It is under the SLA. Good. Wonderful. Now the second transaction. You see, this second transaction belongs to the project called Buffer, belongs to the script called account summary. This is the second transaction in the same script. And this is checking the account summary script. Okay. Again, it's a simple script. So simple transaction. So the SLA is 2 seconds and what you have achieved is 1.5. So it's good. Okay. Now let's look at the third transaction. Again, the project Buffer belonging to the script called account summary. If you remember, what is the first script that you have executed? What is the first script you have executed? Account summary. How many transactions you have in this script? 4 transactions. What are those 4 transactions? Let's go through those 4 transactions in the account summary. The first script is the account summary script. You have 4 transactions in the account summary script. Okay. 4 or 3. Let me see what I have done. Okay. Hang on, guys. So 1, 2, 3, 4. Okay. Okay. So there are 4 transactions in the account summary script. First is the login transaction. Second is checking the account summary. Okay. Second is the checking the account summary. Checking account summary transaction. Okay. Checking account summary transaction. Okay. Third one is back to home. And fifth one is logout. Okay, so these are the 4 transactions which are there in this account summary script. Okay, usually there are some naming standards for the transactions. So these are the naming standards I have given for these transactions. Okay, these are the naming standards I have given for these transactions. Let me copy that. It's not pasting. Let me paste it here. Yeah, it pastes it good. Paste it over there. So hang on. So hang on guys, hang on. So always remember guys, one script can have multiple transactions. One script can have multiple transactions. Let's say the first script is account summary script. Okay, in the account summary script, these are the transactions. What is that? Login transaction, checkout account summary, back to home, and logout transactions. Let's assume, just for our discussion purposes. Okay, these are the naming standards you have given for these transactions. For account summary, what is the transaction name you have given? Buffer is the project name. Account summary, this is the transaction 1, T01, and login transaction. You see, the transaction name comes at the last. Okay. Now again, for the check account history, what is the name that you have given? Again, buffer, the project name, the script name, which is the account summary script. Okay. This is the transaction 2 and the transaction name, which is the check account summary. Similarly, the third transaction, again the project name, the script name is similar. This is the transaction 3 and back to home transaction. You see, this is the transaction. Finally, it's a logout transaction. Okay. Same story with the next transactions as well. You see, next transaction is buffer. Second script is statement history script. Okay. You see, what is the second script? Statement history, checking the statement history. Okay. So buffer, and this transaction is check statement history transaction. This is the T01, the first transaction of the second script. Again login. Then T02, select the transaction tab, select the statement tab. Third one is statement history. Okay. Fourth one is statement history next, and fifth one is the logout. So like this, in the second script you have 5 transactions. Like this, the third script will have multiple transactions. Fourth script, like this, you will have n number of transactions. So for this, you have 50 scripts, you could have close to 150 transactions. So for each one of them, you have to compare against the SLA. So for simple transactions, it is 2 seconds. For medium complexity, it is 5 seconds. For complex transactions, it is 8 seconds. So let's assume these are the transactions that you have achieved. And you see here, you observe, let's say checking the transaction history is taking 4.5 seconds. But let's say it is of the complexity level medium, it is 5 seconds. So the SLA is 5 seconds, you have achieved 4.5 seconds. It is good. So like this, you compare against the SLA. If all the response times that you have captured is less than the SLA, then there is no bottlenecks in your system. Then you can go ahead and close your test. If the achieved response times is more than the SLA, then you have to send your code for the bottleneck analysis. Okay. Are we clear, guys? Are we clear all of this, or do you want me to go through? This is the complete performance testing life cycle. I've shown it to you guys. The complete performance testing life cycle, I've shown it to you. If you can understand the last 10 minutes of my class, you exactly know what happens in the real world. From pin to pin, from the starting of the execution, or from the starting of the performance testing all the way to the ending of the performance testing, you clearly know what it is if you understand from my last 10 minutes of the lecture. So any questions, any doubts, or if you want me to repeat it, I'll go ahead and repeat it. Are we clear, guys? Are we clear? Everybody, I'm asking this question to everybody because this is the thing. If you understand this thing, probably you will understand the whole performance testing. And in the interviews, you will be able to confidently talk. You will be able to confidently talk. If they say, sometimes they will ask you the question, okay, please tell me the whole process that you have done in your project. Now you can take this same sample case study and clearly explain to your in the interview as to what is happening. Okay, this whole sample case study. I've given you the NFRs, sample NFRs, which is probably as close to the real world. And after taking the NFRs, I told you what you can get out of the workload modeling. Okay. So, Susie, is there a particular point that you haven't understood, or the whole thing you haven't understood? I wanted to clearly understand that. If it's the whole thing, what I will do is after the class, I'll sit with you, only with you, and I will go through the whole thing very clearly with you. Probably I'll take half an hour time and then. But if there is only a particular thing that you haven't understood, probably I'll try to explain. So that's the reason why. If it's a whole thing, what I will do is I will do it with one-on-one with you. Susie? Don't be shy. It's totally fine. Some people will not get it the first time. So I wanted to understand. Okay, one-on-one. So I'll take the thing with Susie one-on-one. Okay. So if somebody after the class are willing, they can stay back and they can listen. So probably it will go for 15 to 20 minutes. Okay. It will be one-on-one with Susie. If somebody didn't understood 100%, they can stay back. They can stay back. Okay. Then shakedown test we have discussed yesterday. It's fine. Okay. But Susie, please remind me. Okay. Sometimes what happens is I'll be talking so much, right? With all that in the mind, I might forget. So after the class, please remind me. I want every student of my class to understand most of the things, at least that's what I wanted to do, at least, from my side. Now, this is the most important thing, guys. Okay. So this is the most important thing. Pay attention here. Okay. So pay attention, the LoadRunner architecture, So Kumar, we have looked at the architecture of the application and the test. The LoadRunner tool also have the architecture. Yes, the LoadRunner tool also have the architecture. Let's try to understand. Okay. So hang on, guys. Hang on. So there is some background noise. Let me see, where it is coming from. Can you please mute it, guys? All of them, I request. I never mute anybody so that I give all the privileges to speak. Okay. But there seems to be. Sridhar, you have to wait. We have to spend a lot of time on that workload modeling. Why get confused ourselves? You're planning to attend all my classes, right, Sridhar? You're planning to attend all my classes? Then you have to wait, okay? I'll give you a wonderful explanation. Just like, for everything, we'll take very slowly. We'll get the basics 100% right, okay? Now, let's look at the architecture for Microsoft Office. Okay, let's look at the architecture for the tool called Microsoft Office. Okay, so why I'm calling this as a tool? Anything which makes our work easy, that's called a tool, right? So this is the basic definition right from our humankind has started, or the race of human being has started. Okay. This human being race has started. There is a definition for tool. We are human beings. Why? Because we have the ability to create tools and use them. Okay, and use them. So that is how we are different from any other. We are different from any other animals. Okay. So tools is what? A tool is anything which makes our life easy. Okay, that's what is a tool. Okay, so Microsoft Office will make our life easy when it comes to calculations, when it wants to store the information, or when you want to present some information. Okay, so let's look at this tool, architecture of this tool. It is very, very simple. You take any system and install the Microsoft Office on that, and that's about it. That's the architecture. So that's a hardware, the host on which the tool is installed, or the software is installed, and the software is lying over there. And when you install the Microsoft Office, there are multiple components that will be installed, like Word, Excel, PowerPoint, and all of them. and you can start using all of them. All of them are lying on the same system. All of them are lying on the same system. All of them are lying on the same system. But unfortunately, fortunately, LoadRunner tool is not LoadRunner tool is not like that. The LoadRunner tool is not like that. The LoadRunner tool architecture is little complicated, but if you pay attention, it is not at all difficult. Okay, so there is an interview question around this slide, so please pay attention. There is an interview question around this slide, so please pay attention. Okay, now, okay, so let's assume as a part of NFRs we have received only 2 performance critical transactions. What are those? Check mail script and compose mail script, and our application under test is Gmail. Our application under test is Gmail, and as a part of NFR collection we have received only 2 scripts. What are those? 2 performance critical transactions. What are those? Check mail script and compose mail script. So what do you do as a performance tester? First you do the workload modeling activity, and you figured out that for check mail how many users are there? 600 users, and for compose mail there are 400 users. Okay, as a part of workload modeling you got those numbers. Wonderful. Okay, the second stage is done. Now as a part of third stage of performance testing life cycle, you have created these 2 scripts. What are those 2 scripts? Check mail script and compose mail script. Wonderful, you have created the scripts. It's all one. Okay, then to make sure those scripts are working fine, you have executed those scripts in the VUgen separately. The scripts have executed fine without any issues. Now it's wonderful. Okay, now the third stage is also done, which is the test design phase. Now you're entering the 4th phase of performance testing life cycle, which is the execution phase. This is where you upload the scripts, you upload or you add the scripts into the controller. Okay, let's go ahead and add it. Now the check mail script is added to the controller, the compose mail script is added to the controller. Okay, now each one is called, what is this each one is called? What is this each one is called? What do you call this? Is there a name for this? For this each one? I want to hear from you guys. What is that name?
Groups.
Wonderful. It's called the groups. Okay, now how many groups you have? You have 2 groups. How many groups you have? You have only 2 groups because you have only 2 scripts. Now both these 2 groups will make what? 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 A test scenario. What is it called? A test scenario. Both these groups is making called a test scenario. Now your test scenario is complete. When can you call this test scenario is complete? For the group, if you give the LG name, and for the group you will give this number of virtual users, this is when you can call this as the test scenario is complete. Otherwise the groups are incomplete, so the test scenario is incomplete. Now wonderful, you have assigned, for each group you have assigned the LGs and the number of virtual users. Do you do it for one group? No, for all the groups. Now your whole test scenario is complete, guys. Wonderful, you are ready to go ahead and execute. You are ready to go ahead and hit on the run button. But before hitting on the run button, let's try to understand what is this purpose of the LGs. What is the purpose of the LGs? From yesterday, at the top of my voice, I have been screaming LGs, LGs, LGs. What are these LGs, guys? LGs is nothing but the component of LoadRunner which will give these virtual users. So you see, you know that this check mail script needs to be executed with how many users? 600 users. Where are the 600 users coming from? The 600 users are coming from the LGs. You see, this is coming from the LG called LG1. Now compose mail needs to be executed with how many users? 400 users. Where are these 400 users coming from? LG2. Where are these 400 users coming from? LG2. Okay, so these LGs are the ones which will give the virtual users. If you are under the impression that the controller is giving these LGs or creating these LGs, you are totally under fault. The LGs are the ones which are giving these virtual users. Not the controller is creating these virtual users. LGs are creating these virtual users. So wonderful, guys. Now we have understood the purpose of the LGs. So now we are ready to go and hit on the run button. Now as soon as you hit on the run button, now see what is happening. As soon as you hit on the run button, the checkmail script will be downloaded onto this LG1 machine. Why? Because you said so. Because you said so. This checkmail script, the checkmail script will be downloaded onto the LG1 machine. Okay? And compose mail script is downloaded onto this LG2 machine. Compose mail script is downloaded onto this LG2 machine. Why? Because you said so. Why? Because you said so. Okay, so far it is clear. Shraddha, I'll take all those questions little later. Let's try to understand the first whole the process. Okay, I hope so far it is clear. Okay, so check mail script is downloaded onto this LG1 machine and compose mail script is downloaded onto this LG2 machine because you said so. Because you said so. Okay. Now, what happens? Now the LG1 machine is supposed to create how many users, guys? LG1 machine is supposed to create how many users? Please tell me. Okay, 600 users. 600 users. So LG1 machine has given out that 600 users. LG1 machine has given out that 600 users. LG2 machine has given out the 400 users. Now all these 600 users will start executing this check mail. And all the 400 users will start executing this compose mail script. Let's say this is our application under test for the Gmail. This is our application under test for the Gmail. Okay, so you know any application usually typically have a web server, will have an app server, and will have a database server. We'll have the web server, we'll have the app server, we'll have the database server. Okay. Similarly, this application, our Gmail application, has this web server, app server, and the database server. So as the users are executing this check mail, a request is sent to this application under test, and you get the response as well. Similarly, from the LG2 ones. So this is what going to happen for the next 1 hour, because a test would run for what? 1 hour. Continuously 600 users will be executing this check mail for how many hours? 1 hour. These 400 users will be executing the compose mail script for how many hours? 1 hour. So 1 hour, the request will be sending to the application under test. You'll get the responses back. Similarly, same thing is happening. As this is happening, the results will be captured by the LG1 machine, and also results will be captured by the LG2 machine. Okay, so once after that 1 hour test is done, now once you stop the test, LG1 results will be downloaded or sent back to the controller. Similarly, LG2 results will be sent back to the controller. Okay, this is after the test is stopped. Now both the LG1 results, LG2 results will be combined by the controller. There is a special word in LoadRunner, or special word in LoadRunner LR for combining these results. Okay, combining the results. Okay, there is a special word for combining the results in LoadRunner. Any guesses? What is that word? Any guesses? What is that word? Any guesses? Collating. Okay, for combining the results, there is a special word called collate or collating. Okay, now the results will be collated. Now you can open these results in the tool called analysis for doing the further analysis. In these results, what is that one important thing that you look for? What is that most important thing that you have to watch out for in that collated results, guys? What is that one important thing that you wanted to look at? I want to hear from all of them. The response times. We have discussed this. In the results, the most important thing that you wanted to look at is the response times. Okay, so that's what you will start with. If all the response times are under the SLA, you will happily close this cycle and you make a party. Okay, you go out with the team lunch. Every 3 months people go, right? As a part of projects, this is what we do. After one cycle is what? 3 months. Okay, it is successful, then you go out, make party and have fun and all that. Okay, then otherwise there is an issue, then you send it to the bottleneck analysis. You performance engineers, developers, network admins, system admins, all the people, developers, will sit together, database admins. Now you start figuring out what is the issue. Pinpoint the bottleneck. We have discussed that, pinpointing the bottleneck and all that also. We have discussed, how we will do it. So this is what clearly what is a LoadRunner architecture. Shraddha, I know one question is pending from you. Okay, but that question will be answered soon in my next slides. Okay, I'll not specifically answer because it will be automatically answered. Any doubt, guys, or should I go through the whole process again? Should I go through the whole process again? Any doubts? Any doubts? Any doubts? Okay, quickly again I'm telling you, you got the NFRs. As part of NFRs, you got only two performance critical transactions. Okay, one is the check mail and one is the compose mail. Check mail and compose mail. So you have created the scripts in the VUsers. Make sure the scripts are working fine. Then you upload the scripts. Then you upload the scripts into the controller, and in the controller you design the scenario. Each one is called group. When can you say group is completed? When you assign the LGs and the number of virtual users. Where will you get the virtual users from? From the workload modeling sheet. So once this whole test scenario is done, now you hit on the run button. Once you hit on the run button, automatically the scripts will be downloaded onto this LG main. Here we have decided that we're going to execute. We use two LGs, each LG for each script. But that may not be the case. So you can have two LGs in each group, or same LG can be repeated across multiple groups depending on the capacity of the LG. Depending on the capacity of the LG. If LG one machine could give 1000 users, so you could have used only one LGs. But assuming that each LG capacity is 600, so that's why I have taken two LGs. And also I want you to understand that you can have more than one LGs. Always remember that each group can have more LGs, or the same LG can be repeated across multiple groups. Now once you hit on the run button, these scripts will be downloaded onto this LG machines. What is happening? Why is it processing? Okay, hang on. Okay, so I'm in the middle of the recap, guys. So let's go through that recap again. Okay, not from the first, but from where I have stopped. Okay. So now the scripts are downloaded onto this LG1 machines and LG2 machines, and LGs are the ones which will create the virtual users. As the virtual users are running the scripts, okay, the same script can be assigned to any number of virtual users, right? That we have discussed. Okay, so this will be executed. As it is executed, it is applying the load on the application under test. This 600 and 400 total load of 1000 users will be felt by this application under test. This application under test is the Gmail application. So you are loading this Gmail application with 1000 users. Once this test is executed for how many hours? 1 hour. Once 1 hour test is done, you will have the results for both LG1 and LG2. As a performance tester, I don't want it to see these results separately. So what automatically the controller will do? It will collate the results. After collating, you will have one single result file from both the LGs. So this results file, but for viewing purpose, for the better viewing purpose, you open that result file in the component called analysis, and you start looking at the response times and other stuff. The other stuff, I'll tell you what is that other stuff. So this is what the LoadRunner architecture is all about. Okay, so in the interview, they might ask you what is an architecture, but very rarely. Okay, but they will definitely ask you this question. Where are the scripts executed? Where are the scripts executed? Now, can you please tell me where are the scripts being executed in your load test? Options: VUgen, controller, or LGs. Where are the scripts being executed? Again, listen to the question very carefully and answer. Where are the scripts actually getting executed? Not visually. Where are the scripts actually getting executed? Very subtle question, but it will tell you that you know LoadRunner or not for the interviewer. Where are the scripts getting executed, guys? Where are the scripts getting executed? Okay, LGs. This is a very, very important answer. Okay, the scripts are getting executed in the LGs. You know, once you hit on the run button, the scripts will be downloaded onto these LG machines, and these LG machines will give those 600 and 400 users, and the scripts are getting executed on the LGs. Okay, so this is a very, very subtle question, but it gives them the clear understanding whether you know LoadRunner inside out or not. Okay, that you know the LoadRunner inside out. Okay, so we'll take a break now. Once I come back, we'll start looking into the LGs. That kind of answers our Shraddha's question as well. Okay, we'll try to complete the theory part today, and then we'll decide whether we need to go with the workload modeling or we'll start with the group. Okay, so please come back in 10 minutes. Whoever is having the audio issues, please go out. Any issues that you have, guys, it is probably because of your network. Anytime, okay, today, tomorrow, or through this 1 month, any issues do you have with the go-to meeting, okay, just go out, okay, just log off and log back in. All your issues will be sorted out in general. And also download that go-to opener. Whenever it is prompting you to download that go-to opener, download it and attend from that, not from the web. When you are attending from the web, you will have a lot of issues, because I'm getting a lot of messages that you're having connection issues, but please look into that. Okay, started. I hope it's 10 minutes. So Lashin, go ahead, ask your question. My speakers are up. Lashin, go ahead, ask the question. Okay, so if for example we have 50 scripts, does it mean we have 50 load injectors? No, I'll answer that question, Lashin. Shraddha had the same question as well. All those questions will be absolutely clear in my next slides. Okay, just hold on. Okay, now so by the end of the class, if you still didn't get the your question answered, I'll certainly answer that. Okay, now everybody, now the next question is, where are these components installed? Okay, we know there are 4 components. Where are the components installed? Okay, so let's see where are the components installed in the real-time setup, and where are the components installed for our sessions, for our practice. Okay, so our VUgen, you see, this is the first component, which is VUgen, is installed on the performance testers machine. Okay, is installed where? On the performance testers machine. Okay, are you able to see the screen and hear me, guys? Are you able to see the screen and hear me? Can somebody answer? Yeah, others? Yeah, thank you. Okay, so wonderful. So now you see where it is installed, the VUgen in the performance testers machine. Okay, the controller, we have a separate machine. You can take in the company, there are lots of machines. Okay, if there are no separate machine, order for one. Okay, and then install the controller on that. So what you do is you install the whole tool on that machine. You take a machine and install the whole tool on the machine, but you use only the controller of that. You use only the controller. And the third one, analysis, again is installed on the performance testers machine. Okay, so they will be giving you a desktop or a laptop. On the desktop, laptop, you will be able to see the VUgen as well as the analysis. But you will not be able to see the controller. Even though you will be able to see the controller, you are not supposed to use it. In general, I am saying, okay, but it changes from company to company and all that. But typically in the companies, they will separately install, they will make a separate machine for the controller. They will make a separate machine for the controller. I'll also tell you what is the reason as to why it has to be a separate machine. Okay, and let's assume in our discussion we have 2 LGs, but you could have 5 LGs, 10 LGs depending on the requirement. So for my project, I just had 1 LG, guys. So this is again a separate machine. You take a separate machine and install this LG software on that. So this becomes an LG1, and you take another separate machine, which is machine 3. Okay, so machine 1 we have used for controller, machine 2 you are using for the LG1, and machine 3 you are using for LG3. So you take some completely different machine and install the LG software on that, so which becomes the M3. So you have M1, M2 and M3. 3 separate machines. One you use for controller 1, controller, and second one for LG1, so third one for LG2. And if you have more LGs, you make more machines, and you can install the LG software on it, and you can have as many LGs as you wanted. One thing you need to make sure is this connection needs to be established. Connection between, So connection between this LG and the controller needs to be done. Okay, the machine LG2 and this controller needs to be done. Okay, only if the connection is established, then the scripts can be downloaded from this machine to this machine. That connection I will show you once I'm demonstrating the controller. I'll be able to show you how to connect the controller to this LG machines, how to connect the controller to the LG machines. Okay, only once I'm demonstrating the concept called controller, I'll show you how to connect LG machines to the controller. How to connect LG machines to the controller. Okay, I'll be able to show that to you. Or else, I'll show it now. Just hang on. I'll show it now. Okay. Once this is done, I'll be able to show that to you. It's not that difficult. It's just a 2-minute job. Okay. Again, I'll repeat it in a real-time setup. This is how typically it will be. Okay. This is how it will be typically. But it doesn't mean that in my company, in my setup, it is little different. Yes, it could be different. But general, I am saying this is ideally how it should be. Okay, so VUgen will be installed on the performance testers machine. Analysis is installed on the performance testers machine. Controller, it could be installed on a separate machine. Okay, LG1 on a separate machine and LG2 on a separate machine. And these machines needs to be linked, M1 and M2 and M1 and M3, so that the controller is linked to LG1 and the controller is linked to LG2. This is how it should be. Now the next question is, however, when we install, this controller is installed on my machine. So why can't I use the controller which is there on my machine? So here is the thing, guys. Typically what happens is, in a company, there could be 4 to 5 performance testing resources who will be doing the performance testing. Okay. If you're buying a different controller machine, okay, so it will become little messy as to who is working and who is starting the test and all that. It becomes a mess. Okay, so that is the reason why they keep a dedicated control machine on one, so that this machine can be shared across all the performance testers. Okay, you remember we have to buy the license for the LGs or the virtual users, and these virtual users will be kickstarted from the controllers. So you cannot have too many virtual users. The company buys all the virtual users that is bought will be shared across all the performance testers. So this is the reason why they install the controller on one single machine, and this machine will be shared across all the performance testers. For example, in my company, there were 7 people, 7 performance testers. For all the 7 performance testers, okay, 7 performance testers, okay, we just had 1000 virtual users. Okay, each one doesn't have 1000 virtual users. All of them have 1000 virtual users. Now, if I am executing the test, okay, if I am executing the test, what I will say is I'll book the slot. Let's say from 9 a.m. to 12 a.m. Okay, 9 a.m. to 12 a.m. Which means that this controller machine, I'll be using from 9 a.m. to 12 a.m. Nobody else will be using. In this time, I'll do whatever I want. Now, after 12 a.m. is done, the performance tester 2 will be booking the slot. He would have booked it from 12 a.m. to 3 p.m. So he will be using this controller machine from 12 a.m. to 3 p.m. which means that all the 1000 users now can be used by the performance tester 2. For me, like I have used it in this time slot, and all the 1000 users are available to me. Okay, it is simple, guys. In your house, you have only one laptop, and everybody wants to use it. You book at time slots, right? I'll be using for 1 hour, you will be using for second hour, you will be using for another hour. So you book at time slots and share across that laptop across all the people. Similarly, we have only 1000 users. So we are booking the slot across all this. We are sharing the 1000 users across all performance testers. So that is the reason why the controller is installed on a separate machine, and we will share this controller machine. Whoever have to run the test, we just have to share the controller machine. That's the only purpose. Otherwise, there is no reason why you need to install the controller on a separate machine. Okay. Now Lashim has a question. How are the scripts moved within these servers? Okay. Either VUgen to controller, and if they are on the separate machine, copy them, paste them. Okay. So just put it, send it via an email, or there is a shared folder. Usually there is a shared folder across all the companies. Put it on the shared folder and then go to the controller machines, get it from the shared folder, or just email them or copy them. There are multiple ways. You can do whatever you want. So that's an easy job. That's not a difficult thing, Lashim. Okay. So once you get into the real-time projects, you know what it is. So what it is for our session. Now what it is for our session. It's simple, guys. VUgen is installed on the performance testers machine. Controller is installed on the performance testers machine, which is your machine. Analysis on your machine. And there is only one LG which is running for you guys. There is only one LG which is running for you. And I've already shown you that LG as well. I've already shown you that LG as well. Okay. That is also installed on your machine. Everything is installed on your machine. Okay. Everything is installed on your machine, which I've shown you at the starting. You see, you go to all programs. You go to HP software and you see analysis controller VUgen is installed on the machine, and you can also see that a LoadRunner agent is also installed on the machine. So everything is installed on your laptop itself, or desktop, wherever you are doing. Okay. So now I'll show you the connection from the controller. I'll show you how to connect the controller to the LG machines. It is simple, guys. Watch carefully what I will be doing. First I'll open the controller. Okay, first I'll open the controller. Yes, if there are multiple performance testers in your project, Majid. Okay, if there are many performance testers in your company, then you book the time slots. If you go into that company, right, they will tell you, you get a feel for as to what needs to be done. But typically this is how it will be. So you book the time slots. There will be one volunteer who will be managing the time slots, and you will be booking the time slot. Maybe 1 day prior or 2 day prior, you book the time slot, so which will be yours. Okay, so that's how it goes. Okay, that's how it goes typically. Again, it's not a rule of a thumb. If you get into the project, you will know your own rules and regulations as to how they are using, how many controllers we have, how they are using, and all that. Okay, now I'm going to show you this part. How to connect the LG machines to the controller. Watch carefully. This is my controller. Don't get overwhelmed looking at it. There are multiple panes and all that. Don't worry about it. Right now, just concentrate on how to connect the controller to the LG machines. What am I showing now? How to connect this controller to the LGs. Okay. So how to make that connection? Okay. Go to scenario. Go to load generators. You see, this is already connected. Let me delete that. Okay. Right now it is empty. Okay. Now I wanted to connect an LG called localhost. Go to add. Localhost is the machine or the LG that I wanted to connect. Okay, in the real world you don't have LG1, LG2, LG3 machine names. You will have, typically they will give you what are the machine names. Okay, localhost is the LG that I have, that I should connect. For you also, this localhost LG is there. Okay, so the LG is installed on the Windows based. You see, mine is a Windows machine and the LG is installed over here. If you have any doubts, you can go and look at it, right? Okay, LoadRunner agent process. Where it is installed? It is installed on my machine. My machine is a Windows machine, so select the Windows machine. But in case if they tell you that LG machine is somewhere else is installed and it's a Unix machine, then you can select that Unix machine, Linux box. Okay, otherwise it's a Unix box. Okay, just click on OK. Now you see the LG machine is being added. Now the connection is established. Between the controller and the LG1 machine. Okay, now to make sure the connection is 100% right, you click on connect. Okay, if the status is ready, if the status comes to ready, then the LG has been properly connected. Now I'll try to add one more LG. There is no LG called LG1, honestly speaking. Nowhere you have this LG, but let's assume there is an LG called LG1, okay, which is installed and which is there in your network. Okay, let's say that's a Windows machine. Now click on OK. You see, LG1 is added. Okay, now there is no real machine called LG1. If I try to connect, it will say connecting, and finally it will fail because there is no real machine called LG1. But in your network, if there is a real machine called LG1, which is already there, up and running, and now you say added and you say connected, the status of that will be ready as well. Like this, you can add as many LGs as you wanted. But to make sure they are connected, you can just say connect and make sure it is connected. But there is no real LG1, LG2 machines. That's why the connection has failed. if there were some real machines on which I have installed this LG and it is there within your network, automatically that will be connected. Okay. So now I'm gonna delete that. So it's a very, very simple step. It's not at all difficult. Okay. So if it is a real machine, okay, if it's in the real world, wherever you have installed the LG, wherever you have installed the LG, that LG will have a computer name or a machine name. You see, let's say the LG is installed on this machine. What is the machine name here? How did I get to this point? Go to computer, go to properties, and once you go to properties, every machine will have a machine name. So here my machine name is 3PC. What is it? serr.pc. So that will be the machine name. So try to add that machine. Try to add that machine 3-PC, and now you click on OK and you click on connect. It will be connected. Okay, like this. Or every machine will have an IP address. If you want to have an IP address, go to command line, okay, and go to ipconfig. What is this? Am I doing something wrong here, guys? Okay, ipconfig, is that right? No. There is no space that I have written. ipconfig. ipconfig is, why it is not recognizing? Hang on. I'm not giving any space. Okay. Am I typing it wrong? ipconfig. ipconfig. Okay. Ping the IP address. Okay, so there seems to be some issue over here. Okay, so okay, no IP. It doesn't matter the folder structure. Anyways, once you enter that IP config, you will get the IP address. You can add the IP address as well. You can have the IP address as well. Let's say that machine IP is 123.2.5.1. You just add that IP address and you will be able to connect to the machine. Either you give the machine name or the IP address of that machine and you will be able to add it over here. You will be able to add it over here. Okay, so that's what it is, guys. That's what it is. Okay, that's what happens in the real world. That's what happens in the real world. Any questions so far, guys? Any questions so far? Any questions so far? So now our Shraddha's and what is that? Lashim questions will be answered. Let's see. Okay. So wonderful, guys. Wonderful. So we are going very smoothly, very nicely. Okay. I hope you are understanding a lot of points. Even though who are in the performance testing world, they are learning some new things every day. I hope. Okay. Okay, so let's see what is this load generators or LG machines. You got already a ballpark idea as to what it is. Okay, LG machines are the ones which will give the virtual users. What are those? Those will give the virtual users. We know performance testing is not done by real users. It is done by the virtual users. So these virtual users are coming from where? Not from the controller, from the LG machines. LG machines are from where these scripts will be executed. Okay. Now, how do we know how many LGs we need for the projects? Okay, do we need 1 LG or 2 LG, 3 LGs? How many LGs we need for the project? What is the best number for the LGs? Okay, how do we know how many LGs we need? Okay, let's say we know we have to take a machine. On this you install this LG software and this becomes a LG. How do I get to the LG software? Again, I'm telling you guys, look carefully. Okay, so when you go to this installation, this is the installation folder I have given. Okay, when you double click on this setup, everybody would have done. Okay, what you have done is LoadRunner full setup. What you have done is LoadRunner full setup. But if you want to install only the load generator, okay, you just click on this load generator. Whatever the machine that you want to make it as an LG, okay, take that machine. Whatever the LG, whatever the machine that you want to make as an LG. Let's say I wanted to make this desktop as an LG. Okay, take this, open this, put this, copy this complete folder structure on that LG machine. Copy this folder structure on the LG machine. Double click on the setup. Don't do LoadRunner full setup. just install the LG software. Just install the LG software. Now that machine becomes the LG machine. Now that machine becomes the LG machine. What did you do? Take any machine, double click on the setup, just install the load generator software on that, and that machine becomes the LG machine. That becomes the LG machine. Now you see, I've taken this machine and put that setup file, double click on that setup file and install the LG software. Install the LG software on that. Now you can call this machine as a LG machine. You can make any number of machines as an LG machine. It's not an issue at all. Just for the discussion purposes, the machine on which this LG software is installed, let's say it's a 2.3 gigahertz processor and a 500 MB RAM. Okay, now nobody is using a 500 MB memory. Okay, but let's say it's a 500 MB memory. Now you install this LG software. Now this machine is called what? LG machine. Now this machine is called LG machine. Like this, you can take another machine, install the LG software. That machine becomes an LG machine as well. Like this, you can make any number of machines as LG machines. And I've already shown you how to connect the controller to the LG machine. So no big deal at all. Okay. So we already know this machine is different from the machine on which our controller is installed. Okay. Now, number of users this LG can support totally depends on something called footprint. Okay. So you have taken this machine. How much of memory it has? How much of memory it has? Please tell me, guys. How much of memory it has? 500 MB. How much of memory it has? Let's assume it is a 500 MB. We already made that assumption. Okay. So now how many virtual users this machine can give out? It is definitely not infinite. It is definitely not infinite. There is a limit. There is a limit. Okay. So this machine I have taken. What is that machine? A 2.3 gigahertz processor. 2.3 gigahertz processor. Okay. 2.3 gigahertz processor and 500 MB machine. Okay, 500 memory machine you have taken. You install the software called LG. I've already shown you how to do that. Okay. Now how many virtual users this machine can give out or support? Okay, give out or support. How many? Okay, definitely it is not infinite. Okay, there is a finite number of users. It can give out. Finite number of users it can give out. Okay. Let's see what is that number. Let's see. That number totally depends upon something called memory footprint. Okay. Now watch carefully, guys. This memory footprint. Okay, memory footprint totally depends on the protocol. Okay, so memory footprint totally depends upon the protocol. For HTTP, okay, this whole course is for web HTTP HTML protocol. For HTTP HTML protocol, the memory footprint is 2.3 MB. For SAP GUI protocol, the memory footprint is close to 10 MB. Okay, and for other protocols, it's a different number. Now, what is this? What is this 2.3 MB? What is this 10 MB? Let's convert that to English statement and let's try to understand. Okay. The memory footprint is 2.3 MB means for one virtual user, okay, for LG machine, okay, look at this statement very carefully, guys. For LG machine to give out one virtual user, it requires 2.3 MB of memory from its RAM. Okay, so this is what it is. Okay, to give out or to manufacture that one user, or to give out or to create that one virtual user, how much memory it has to spend? The LG machine, 2.3. In our discussion or in our example, what is that memory of our RAM? What is the memory of our LG machine? In our example, what is the memory of our LG machine? What is the memory? I want to hear from everybody, guys. I know it's a long session, but please be active. You see, I'm pushing myself to be energetic, and I need more energy. That energy comes from you. That energy totally comes from you. I have to get that confidence that you're listening, you're actively listening. Only then I will have the energy to speak. Okay. So speaking for 1.5 hours continuously, I mean, with 10 minutes break is still a lot of energy, guys. Please give me that energy by giving the answers. Okay. So I don't have unlimited memory on my system. I have 500 MB. Okay. So one virtual user, memory footprint is 2.3 MB means what? Memory footprint is 2.3 MB is what? So, which means that to create one virtual user, that LG machine spends how much of memory? 2.3 MB memory. But does it have unlimited memory? No, it has only 500 MB. So let's do our math. Okay. For one virtual user, okay, 2.3 MB of RAM is required, or memory is required. Okay, 2.3 MB of, I won't use going forward, I'll be using the term memory only, not RAM. Okay, now I have 500 MB. How many users? Simple high school maths. So replace that question mark with X. Something that you know, that you don't know, you always replace with X. Okay, 500 multiplied by 1 is equal to X multiplied by 2.3. Okay, so that's how it is. That's your maths, right? That's your high school maths, right? 500 multiplied by 1 is equal to X multiplied by 2.3. Let's do that. Okay, 500 multiplied by 1, okay, is equal to, okay, X. Something that you know, don't know, always consider it as X multiplied by 2.3. That's your high school maths. Now X is equal to, this is here multiplication. If you go to the other side, it becomes division. This is multiplied. You have to send it to the other side. It becomes division. Again, high school maths. 500 multiplied by 1 is 500. Okay. Divided by 2.3. Can somebody tell me what it is? 500 divided by 2.3. Okay. You can open your cal. See. Okay. 500 divided by 2.3. How many? Close to 217. You cannot have 217.3. 217.3, so round it off to 217. Okay, so always remember, if a machine has 500 MB, it needs some of its memory for its internal work, like OS, device drivers. Your system has a lot of softwares installed on it, like your operating system, your device drivers, and maybe Microsoft Office and all that. If a system has 500 MB of memory, it cannot spend all the 500 of memory. You cannot have all the 500 MB of memory. Some of it, it needs to install. It needs by itself. You see, for now, hardly nothing is there on my system. Okay. I'm not running, except a PowerPoint and a GoToMeeting. I'm not running too much of the softwares. Okay. You see how much of the memory? I have 16 GB of memory, out of which 3.8 GB of memory is running for the OS, device drivers, some user processes and all that. So how much of the memory that I can use out of the 16 GB? Only 11 GB, close to 11 GB. Similarly, you have a 500 MB machine. All 500 MB you cannot use it. Some of it will use for the OS kernel activities and all that. So it can use probably in the real world. If it's a 500 MB machine, you can use only maybe 300 out of it. Maybe only 300 out of it. Okay. So in that case, the number of users will be little lesser. Okay, so if out of this 500 MB, let's say only 300 MB of memory is usable, then change this to 300. Now you can do a math. As to what it is. Can somebody tell me 300 divided by 2.3, how much it is? Can somebody please tell me? 300 divided by 2.3. Okay, which is close to 130 users. So one machine is giving 130 users. Okay, let's say now give me an answer, guys. You wanted to run with 1000 virtual users. You wanted to run with 1000 virtual users. Each LG is giving only 130 users. So how many LG machines you need? Okay, now I need to run a test with what? 1000 users. Each LG is giving only 130 users. Each LG is giving only 130 users. Now you tell me, okay, each LG is giving only 130 virtual users. Now you tell me how many LGs you need? How many LGs you need? Okay, the total test you wanted to run with 1000 virtual users, but each LG machine is giving only 130 users. So how many LG machines you need? 1000 divided by 130. 1000 divided by 130. Okay, so 1000 divided by 130. Okay, so how much it is? So you cannot have 7.6 LGs. You need 8 LGs. You need how many LGs? 8 LGs. You need 8 LGs. This is how you calculate the number of LGs that you need for your project. The number of LGs that you need for your project. Okay, this is considering web HTTP HTML protocol. Web HTTP HTML protocol. Okay. For SAP GUI protocol, the memory footprint is close to 10 MB. Okay, close to 10 MB. Then you can see, how many LGs you need. How many LGs you need. Okay, so I'm giving an assignment, guys. Okay, it will be there in your running notes or your class notes. This is the assignment. Okay, your project, your scripts. Okay, see carefully. Your scripts are created in using SAP GUI protocol. Okay, SAP GUI protocol. So what is the memory footprint? 10 MB. What is the memory footprint? 10 MB. Okay. Each LG machine has 3.2 gigahertz of processor. And 2 GB of RAM. 2 GB of memory. Okay. Okay, you are running a test. With 1200 virtual users. Okay, calculate number of LGs required for your project. Okay, calculate the number of LGs required for your project. It's not a homework, it's a classwork itself. I want you to do it now. If I say homework, nobody is doing. Okay, so please do it now. Okay, if you want me to repeat, not this assignment, but the understanding, okay, I'll repeat it. But I want everybody to attempt this assignment now and give me the answer now. Okay, so please don't leave off now. I know it's the time, but it will take only 2 to 3 minutes if you can concentrate well, or maybe 10 minutes. Please do the assignments and give it to me. If you want me to repeat the concept again, I'm ready to repeat it. Okay. So see, I haven't forgot. I have to go through the complete the case study for you. So you have to stay back after the class. But please do this assignment before you leave for today. Please do this assignment before you leave for today. Okay. I'll repeat it. Okay. I'll repeat whatever I said through the PowerPoints. Okay. Phil already gave the answer. Wonderful, Phil. I want everybody to look at it. If somebody didn't answer, please look into it. Okay, if somebody didn't understood the memory footprint or calculations of LG, please look into the PPT. Please look into the PPT. Okay. See, memory footprint vary from protocol to protocol. We have already told that for HTTP HTML protocol it is 2.3 MB. Now your machine is a 500 MB RAM. So 2.3 MB is required by one virtual user. 500 MB, how many? Okay, so whatever you don't know, consider it as X. Okay, 2.3 MB multiplied by X is 500 multiplied by 1. Okay, so 2x multiplied by 2.3 is 500 multiplied by 1. X is equal to 500 by 2.3, so it is 217. Typically in the real world, if you have 500 MB, you cannot use all the 500 MB, so you can use only a part of it. So see how much you can use it, and depending on that, you do the calculations. Okay. Now in our example, we wanted to run the test with how many? 1000 virtual users. Now let's see how many virtual users you would need. Okay. So each LG is giving out 217 users. Each LG is giving out 270 users. You need to run the test with 1000 users. You can do your math. Okay. Again, whatever you don't know, you can call that as X. Okay. X multiplied by 217 is 1000 multiplied by 1. So X is equal to 1000 divided by 217. You cannot have 4.6 LGs. So 5 LGs is the case. Okay. So you need total 5 LGs for your project. You need total 5 LGs for your project in this case. Okay. So I'll talk about this. First, let me see how many have given these answers. Okay. So how many have given these answers? Phil. Okay. Phil, they have given the answer. Lashim, 6. Okay. Kida. So you need to complete the answer, Kida. So Mercurian, you have to answer. Okay. That is for 1 LG. So how many LGs you want? Okay. 6. So Rupa 6, Ayo 6. Okay. Wonderful. Wonderful. So watch carefully guys. What is the memory footprint? 10 MB. What is the memory footprint? 10 MB. Okay. What does that mean? One virtual user takes 10 MB of memory. Okay. Each machine is having how many of MB of memory? 2 GB. Okay. Convert that to MB. 2 GB, convert that to MB. Can somebody tell me 2 GB is how much MB? Very lot of people will go wrong here. Okay. At last somebody is from computers. 1024. Okay. So always remember 1 GB is what? Not 1000 MB, it's 1024 MB. Okay. 1 MB is what? 1 MB is what? How many KB? 1024 KB. Okay, and 1 KB is how many bytes? 1 KB is what? How many bytes? 1 KB is what? How many bytes? 1024 bytes. 1 byte is how many bits? 1 byte is how many bits? 1 byte is how many bits? Let's see how many people will answer this. 1 byte is how many bits? This is the basic that you need as a computer, guys. Okay, 8 bits. Okay, this is the bare minimum that you're supposed to know. Okay, now 2 GB is how much? It is 2 multiplied by 1024. 1024. Can somebody tell me how much it is? 2 GB is how many MB? Can you do that math? 2048. 2048. I hope that is right. Okay. You total have 2048. 2048. And whatever you don't know, you can call that as X. Whatever you don't know, you can call that as X. Okay. Now you can do the math. Okay. So 1 multiplied by 2048. Okay, is equal to whatever you don't know, let's call it as X. X multiplied by 10. Okay, so X is equal to what? 2048 divided by 10. Okay, so which will be what? 204. Each virtual user is providing what? 204 virtual users. You can round it off to the nearest number, which is 200. Okay, it's up to you. Okay, it's just the LG calculation. You can round it off to the nearest number. Okay, so each LG, one LG is giving out how many? One LG is giving out how many virtual users? How many virtual users? 200 virtual users. Okay, now I need to run the test with how many? I need to run the test with how many virtual users? 1200 virtual users. Okay, so how many LGs you need? How many LGs you need? 1200. Okay, so how many LGs you need? 1200 multiplied by 200, which is 6 LGs. So this is how you calculate. This is how you calculate. Okay, this is how you calculate. Okay, so a very, very interesting thing that I will show you now, guys. Somebody who has time can stay back. The others who are getting late can leave. So this is not part of the course, but visually you wanted to see the memory footprint. You can see it, and all my life I wanted to do this, so I'll do this as a part of the course. Somebody told me it's 2.3 MB the memory footprint. I've believed and I'm telling you, but I'll see what it is. Okay, so somebody who's interested can stay back and look at this experiment. I wouldn't say this is something which I'm demonstrating. This is just an experiment. I'm doing it. You can stay back and look at the experiment as well, and obviously you will gain a lot of knowledge. Okay, Normally, very rarely you would have to do it. Okay, in the interviews they might ask you. That's why I'm going through all this, but once you get into the project, if it's already the project is running, they would know how many LGs is required. They would have installed the controller, they would have made the connections, whatever we have discussed so far, it would have already been there. So just go ahead and start using it. But just in case if you have to, you can. And once you get into the projects, right, if you have any doubts, send out all the information on my WhatsApp message. I'll do the calculations for you. Don't worry about it. Okay. Okay, wonderful, wonderful. Okay, now, okay, let me add a script and let's run the script. Okay, something called book flights. Okay, let me add the book flight script. Okay, so whatever I'm doing now, just ignore it. The experiment, I'm telling you what is the experiment. Okay, so let's say we'll run with one user. Let's say we'll run this script with one user. Okay, now this is my application under test. I've started the application under test. Okay, so first let's look at all the process. Okay, let's see the process. What is the process? Different processes which are kick-started. Okay, so what do I have? I have the controller open. I have the VUgen. Looks like a VUgen process is already running, which is VUgen.exe. VUgen.exe. Okay. And I have the controller open. Let me see what is the process for the controller. Let me see what is the process for the controller. If you happen to find it, please tell me, guys. I'm not able to find the controller process here. Okay. So if you happen to find it, please tell me. There should be a process for the controller as well. This is the go-to meeting. Okay, there you go. There you go. Okay. WLRun.exe. WLRun.exe. That is the process for the controller. And agent machine process is always running. What is that? Magnetproc.exe is the agent process or the LG process. Now, the LG process, how much of memory it has taken, guys? You see how much of the memory? It is 2.434. To start with, what is the memory of the LG? Let's start looking at the LGs. So, virtual users are given by whom? Not by VUgen, not by controller, but LGs. Okay, let's start looking at the process of LG. What is the process of the LG? Magnetproc.exe process. Magnetproc.exe. And what is the memory right now to start with? What is the memory right now to start with? How much is there? 2.4 MB. Okay, which is 2432 KB, right? Which is approximately 2432 KB. Okay, this is the memory that you have to start with. Okay, now tell me, guys. As soon as I start the test, then this one virtual user has to be created, and this one virtual user will be created by which process, guys? Will be created by which process? Will be created by this agent, LoadRunner agent or LG machine. Okay, and will be created by the process called magnetproc.com. And let's see how much this memory will be jumped. Okay, by creating this one virtual user, let's see how much of the memory will be jumped. We have assumed it is 2.3 MB. Let's check if it is 2.3 MB or not. Okay, now I'm starting this test. Okay, now you see that one virtual user, this one virtual user, which is down, is in the running state. So that one virtual user has been created by our LG. Now let's see how much of the memory it is jumped by. Hardly anything, which is 2.3 MB itself. Okay, so whatever is started with, it is still the same thing. So this 2432 is close to, if you convert it to MB, this is 2.3 MB, guys, because you have to divide 2432 divided by 1024, right? You convert that to MB, you divide it by not 1000 but 1024. Okay, so let me divide that. 2432, okay, 2432 divided by 1024. All I am doing is converting to MB, which is 2.3. So our assumption is correct. For one virtual user, you need 2.3 MB. So this is for one virtual user. Okay. Now I will add one more virtual user. Let's see what happens. Okay. I'll add one more virtual user. Oh, it has already stopped. And okay, hang on, guys. Hang on. Okay, hang on. So whatever I'm doing now, just ignore that. I'm continuously running it for 1 hour. Okay. So let me start the test. Okay, don't worry about all this. Concentrate on only the virtual users. I'll go through the controller very, very clearly. Each tab I will explain, but right now just understand the number of virtual users which are running. Right now there is only one virtual user running, and that one virtual user should be given by whom? I've stopped the server. Oh my god. Okay, so hang on, let me start the server. Okay, so just understand that one virtual user will be given by the LG, which is this magnetproc.com, and how much of memory it has taken for that one virtual user? 243. This is KB. You convert it to MB, it is 2.3 MB. Okay, this is an experiment, guys. I'm just doing an experiment because I'm curious. I want you to involve as well. So that's what it is. So let me add one more virtual user, guys. Let me add one more virtual user. Okay, let me add one more virtual user. Okay, let me add one more virtual user. I've added one more virtual user and I'm running it. Okay, now how many virtual users the test is running with? 2. Both these 2 virtual users will be given out by the LG. Both these virtual users should be given out by the LG. Okay, this number is supposed to increase. I'm surprised this number has not increased. It still says 2432. It still says 2432. This is something which experiment which I wanted to do from long time. Somebody told me the footprint is, all my calculations in the projects, my team has told me. So I went with that 2.3 MB. So you see, the number of the LG is not increased. Okay, so it is still 2.3 MB itself. It is still 2.3 MB itself. So let me add one more virtual user. Okay, let me add one more virtual user. Let me run it. Okay, so right now you are running the test with 3 virtual users. It is still the same thing. So our assumption of 2.3 MB for each virtual user may not be right, because you see you have 3 virtual users, but the memory which is taken is still 2.43. It's still same. So let me add 10. Let me add 10. Let's see what happens. Let's run all the 10. Now you have 13 users. So total you are running with 13 users. Let's see what is the consumption. It is still the same. Wow. Okay. It's still the same. So the memory footprint to start with, it is 2.3. But I think after you add it, it looks like it's, yeah, it can be same, right? Close and open. Okay. Let me add few more. Okay. Let's add 30 users. Okay, I have the license of only 50. Okay, so let's add 30 more users. Okay, so right now there is 43. It's still same. Okay, let me close, and I don't know if it's refreshing. Let me close and open it again. So the memory process is magnetproc, right? Where is that magnetproc? It is still 2.3. Okay, so the calculations that we have done in the class, we will look into that calculations again, guys. So looks like to start with, the memory footprint is 2.3 MB, but for the addition, it looks like if you keep adding the users, it might not be same. Okay, it might not be the same. Okay, but for SAP GUI, somebody told me that it's 10 MB. So let me see if that 10 MB is correct or not. Okay, let me see if that 10 MB is correct or not. Okay, this is just an experiment, guys. People who wants to stay back, they can stay back, because when you're doing the experiment, you will learn a lot. Okay, so so I'll add the SAP GUI script. Okay, some script from my SAP GUI. So I've created some SAP GUI scripts. Okay, let me add the SAP GUI script. Yeah, there you go. Login, logout for SAP GUI. Okay, looks like that script is not there. So let me see, where is my SAP GUI scripts. Yeah, this could be the login, logout. So just hang on, guys. Let me open this script. Okay, let me view the scripts and make sure it's an SAP GUI protocol. Yeah, it's an SAP GUI protocol. Wonderful. So how do I know it's an SAP GUI protocol? You can go to here and it says SAP GUI here. Okay, so this is an SAP GUI script. It's a different protocol. Let's see what it will be for this. Okay, let me go ahead and run this test. Okay, let me go ahead. Now you see the one user has started. Oh my God, hang on. I think in the runtime settings I have to do some changes. Hang on, guys, 1 second. Hang on guys, 1 second. Okay, now this is the SAP GUI protocol and we have assumed that the memory footprint is 10 MB. Let's go check visually if that is true as well. Okay, so this is in the run status. Okay, this is in the run status and you see magnet proc. Come on guys, this is not changing. This is weird. It is still says 2432. Oh, I'm sorry guys. I'm sorry. Okay, I'm sorry. I know why. What is the problem? I know what is the problem. To start the LG, you need magnetproc.exe. Okay. Once the LG is started, now for creating the virtual users, it will use another process called MMDRV. It uses the other process called MMDRV. Okay. So this is what it is. I totally forgot. For LG itself, we use magnetproc. Okay, magnetproc, it use magnetproc.exe, but this LG to create the virtual users, it will use mmdrv.exe. It will use the process called mmdrv.exe. It will use the process called mmdrv.exe. Okay, so no wonder it is not changing. Okay, so you see, now what is it? It is close to 20 MB. It is close to 20 MB. For the first virtual users, it is close to 20 MB. So let me note it down. This is the SAP GUI protocol, guys. This is the SAP GUI protocol. Okay. For one virtual user. Okay. So how much you are getting? 24.552. 24. Okay. It is 24552. Okay, this is KB. You can convert to MB divided by 1024. So it will be approximately 24 MB, I believe. Okay. Now I'll add one more virtual users. Let me see what it is. I'll add one more virtual user. I'm adding one more virtual users. By default, it will be down. So let it get it to the running state. Now the second virtual user in the running state. Now the test is running with 2 virtual users. The test is running with 2 virtual users. These 2 virtual users should be given by what? MMDRV. Now let's see how much is the footprint increased by. It will take a little bit of time to stabilize, guys. It will take a little bit of time to stabilize. Okay. Okay. So for 2 virtual users, how much it is? 27928. Okay, 27928 KB. Okay, so it could be approximately 27 MB. Okay, now it makes sense. Okay, now let's add one more virtual user. Oh, I've added 3 of them, but I'll only run only one of them. Okay, I'll only run one of them. Okay, now how many running users are there? Only 3 running users. You can check it from here as well as you can check it from here. There are 3 running users. And let's see. Now what is the memory that it has jumped to? That 31796. Let it stabilize. Okay, so it is approximately 32,000 KB. Okay, so how many virtual users you have? 3 virtual users. Okay, how much it is? Approximately 32 KB. 32,000 KB. So which could be approximately 32. Some sample is there. 32,612, right? 32,612. And how much of memory it is? 32 MB of memory. So let's add one more virtual users. Let's run this one more virtual user. Okay. Okay. So with 4, you are running the test now with 4 virtual users. Please mute yourself, guys. If you don't have intentions of speaking, please mute yourself. If you have anything to say, please let me know. I'm okay. Okay, which is what? 36,428. Okay, this is 428. Okay, so this could be 36 MB of memory. Close to 36 MB of memory. Okay, so let me add one more users and I will close this experiment. Okay, so I've added one more virtual users. Now there are 5 virtual users running, 5 running virtual users. Let's look at MMDRV. Let it stabilize. Sometimes what happens is after 5 virtual users, it will jump with a bigger number. So on an average, they would have given 10 MB. Okay, so 3853844. Okay, which is KB. Okay, which is 38 KB, 38 MB approximately. Okay, so okay, so let me add 10 of them. Let's see what happens. Okay, let me add 5 more. Okay, and run all the 5 of them. And let's see the jump in the memory. Let's see the jump in the memory. Okay, it will take a little bit of time to stabilize. Sometimes 2 processes, once it goes over a point, 2 processes will start as well. So now we are running the test with 10 virtual users. It kind of hanged up on me, guys, the system. Now we are running with 10 virtual users. 10 virtual users, approximately 58716. Okay, which is KB. Okay, so now you can do your math. Okay, let me stop the test. Okay, now you can do the math as to what it is. Okay, so approximately 6 MB. This is what 58 MB of memory. So now you can see how much it is for one virtual user. With my experiment, one virtual user, you see with 10 virtual users, how much of memory it is consuming? Close to 58 MB. So for one virtual user, it is close to 6 MB of memory. Even though somewhere I've read it is 10 MB, but with the little experiment that we have done, it looks like 6 MB. Okay, nowhere in the internet, nowhere it's published as to what is the memory footprint for each virtual user or memory footprint for each protocol. It is kind of hard to figure out. I've downloaded this from somewhere, like, I've downloaded this memory footprint document from somewhere. Okay, but I'm not quite sure about that, what it is. But this little experiment that I've done, you can see for SAP GUI protocol, it is the memory footprint seems to be 6 MB. Okay, so we can do the same experiment for the booking flights as well. Okay, we can do the same experiment for booking flights, which is the HTTP HTML protocol as well, and you can see. Okay, in the house you can see this. Okay, so what it is for booking flight. Okay, so let me do it. Okay, if you have time, whoever have time can stay back. Others, it's okay if you leave. So this is for HTTP HTML protocol. One virtual user. Let me see what is the memory footprint. Okay, let me see what is the memory footprint. Somebody who you are interested can stay back, guys. So there should be MMDRV. Can you see where is my MMDRV here? Yeah, there you go. So for first virtual user, it has taken close to 4 MB. For the first virtual user, it has taken close to 4 MB. So let me add one more. Okay, 4.4. It has increased by 0.5 KB. Okay, it is increased by 500 KB. It is increased by 500 KB. Let's run one more. Yeah, it is increased by 500 more. Okay, so 500 KB seems to be the footprint for each virtual user. So yeah, it looks like let's run 10 of them and let's see what it is. Now how many? 8 are running. So let me run 2 more. So now there are 10 virtual users. Let me see the memory footprint. Okay, so how much is this? So close to 10 MB. So per one virtual user seems to be 1 MB for one virtual user. Looks like. Okay, so let's run 20 virtual users. Let's see what happens. Okay, how many is there? 21 is there. Let me stop one of them. Okay, now it is running with 19. Okay, let me run one of them. Okay. Okay, now it is running with 20. Now it is running with 20. Close to 16. Okay. As the number of users are increasing, the memory footprint is decreasing. It's not linear. It looks like it's not linear. So it seems like for 20 it is 16 MB. Then it was 0.8 MB for each virtual user. That's what it looks like. 0.8 MB. Okay. So 0.8 MB looks like. Okay. That's just a guess. So this is how you can look at the memory footprints, guys. This is how you can look at the memory footprints. So even though in the assumptions, we made 2.3 MB, but it doesn't seems to be, at least on my machine, it doesn't seems to be. Okay, so that is the ballpark numbers with which you can make those calculations, guys. But you can clearly see over here and see how much this is using, and based on that you can make the calculations. Based on that it will makes the calculations. Okay, so I hope my little experiment made sense to you as to look at what is happening and all that. Okay, looking at it, so somewhere I have downloaded a document for the memory footprints. Okay, let me see. I store it at different places, guys. So funny that I don't have it at a place. So let me see if it's in email, or somewhere, wherein I do it. Okay, footprints. Hang on, let me search. Let me save memory footprint. Okay, let me see if I could find any document with that name. Okay. Okay, there you go. I got a document from one of the students. This document. Okay. If somebody is interested, we can look at this document. Okay. So let's see. For web HTTP HTML, it depends upon, looks like it depends upon the complexity of the scripts. High complexity scripts, 50 virtual users. Okay. This seems to be 5.2 MB. Okay. Seems to be 5.2 MB. If it's a Windows 2, it also depends upon what kind of machine you have. Windows 2000, Windows XP, Windows this thing. Okay. It also depends upon the kind of machine you have. Okay. Let's see if it is a Windows 2003 machine. Okay, it seems to be 4.9 MB. Okay, footprint. Okay, so if it's low, then 4.5. SAP GUI 36.6. Okay, as per this document. Okay, as per this document, this is for how many users? This is for how many users? 30 users. Okay, so that it is for the number of users they have given. Okay, so they said for 50 users it is 5.2 MB. Okay. 50 users, it is 4.9 MB. So it is not for one virtual users, it's a bunch of users it is. Okay, so this is what it is. Okay, so for Citrix for 10 users it is 5.7. For SAP GUI for 50 users it is 11.5. So for 10 users we approximately got somewhere around 30. Okay, so looks like this thing is correct. So you can look at this thing, guys. You can look at this spreadsheet and you can look at the memory footprints. Okay, depending on the number of virtual users. Okay, so for 50 users, depending on the machine, the numbers would footprint will looks like the memory utilized will change. Okay, so you can see. Okay, for true client definitely it is high. For true client it is high. Okay, so where is the true client? Can you see where is the true client, guys? I'm not able to see. For SAP GUI, it is 4.3. I couldn't see that true client. Okay, I don't see it here in this document. But this is a nice document. In case if somebody wants it, I'll send this across to you. For 50 users, what is the memory that is required? It is clearly given out here based on the protocols and also based on the complexity levels. So I cannot double check if this document is correct or not. Whoever has forwarded this document looks like it is from the HP guys or Micro Focus guys itself. So I'm sure it is right. So you can do the little experiment that I have done. This process over here is the MMDRV process. Okay, you can run a test with 50 users and see if this is matching or not. But looks like it matches. Okay, that's what I have heard, Phil, as well. That's what I have heard. Okay, so this is what is the memory footprint is about, guys. So whatever the calculations that we have done is based on what I was told or what I have learned from the HP guys, that 2.3 MB memory footprint, but that doesn't seems to be right as per the numbers are concerned. Okay, as per the numbers are concerned, that doesn't seems to be right, but it is okay. At least you have understood how to make the calculations or how to do the calculations. Okay, but this spreadsheet seems to be from the HP guys, so you can trust this spreadsheet, and based on the number of users, you would know how much of the process is required or how much of the memory is required. Okay. Somebody has asked me, do you have to do the calculations? No, you have this spreadsheet. You need not have to do the calculations. You keep this spreadsheet and you would know how many virtual users are required. I mean, how many virtual users with which you have to run and what is the memory that you have. And based on that, you can do your math. Based on that, you can do your math. Okay. Sorry for that that calculations 2.3 memory footprint. That is based on my knowledge. Okay, so looks like it is little different from here, little different. Okay, even the experiment proved that those numbers may not be right. The footprints that I have given may not be right. Okay, so even this one seems to be from HP, so you can blindly go with these numbers here. Okay, for 50 users, seems like 5.2 MB is the process, or DRV process is required. Okay, so based on that, you can look at the you can do your math or the calculations. Okay, so we are wrapping up the class today, guys. If somebody needs this Excel sheet, please let me know. I'll send this Excel sheet across to all of you. Okay, so if somebody needs, please tell me. Okay. So this is what it is. Okay, so I'll send it to all of them. Irrespective of whether you need it or not, because at some point you might need it. Okay, at some point you might need it, so I'll send it across to you, all of you. Okay. Okay, so now Susie, are you there? Somebody who has questions then can stay back. Susie, are you there?
Yes,
thank you, Majid.
Kumar.
Okay, now we'll peacefully go through this. Okay, so somebody has any questions, please ask me the questions right now before I start this for Susie. Okay.
Can you hear me?
Yeah. So watch carefully here, Susie. Okay, now this is a sample case study. Okay, based on the assumptions, I'll clearly tell you what will happen in the whole project. Okay, what will happen in a project. Okay, now, okay, watch carefully this, Susie. So let's say the first stage of performance testing is NFR collection. Okay, as per NFR collection, this is what we have received, Susie. What is it? 50 performance critical transactions or business process. Okay, our application under test is banking application. Let's say it's a BOFA. Okay, Bank of America. Okay, now there are 50 performance critical transactions or business process you have collected as a part of NFR. Who has given you this information? The client has given you this information. Now you put this information, you store this information. And client has already also given you that load test needs to be executed with how many virtual users? 1000 concurrent virtual users or 1000 concurrent users. Okay. Okay. So this is what the basic information you have collected from the client. Now, what you do as a performance testing team, you create 50 scripts for this performance critical transaction. Sagar, I will call you back. Okay. After the class, I will call you. Okay. So PT team has created how many scripts? 50 scripts for this 50 performance critical transactions. Wonderful. You have created the scripts using VUsers. So it's all done now. It's good. Okay.
Kumar?
Yeah. Go ahead, Susie. Susie, can
Kumar?
you? Yeah, I can hear you. Hello, I can hear you, Susie. Go ahead.
Hey, Kumar.
Yeah, I can hear you.
I can hear you. Oh, you can hear me now? Okay.
Okay. So can you hear me?
Yes, I can hear you now. Sorry, I was using the headphone.
Okay. So is it clear so far now? Or should I repeat that again?
Are we doing this one-on-one or as a group?
No, one-on-one. Let others be there, not an issue. Let them listen. But you can speak. This is only for you.
Susie, is it fine?
Yeah.
Yeah. So now you see, Susie, as a part of
Yes.
NFR collection, PT team has received following. What is the PT team has received? 50 performance critical transactions or business process. Okay. So, and then the load test is required to be executed with how many users? 1000 concurrent users. Are we clear so far, Susie?
Yes.
Okay. This is what we have collected. Now, what is the performance testing team will do? It will create 50 scripts for all these 50 performance critical transactions. Okay. It is created in what?
Okay.
In the VUgen component. Okay. Now,
Okay.
what PT team will do is they will execute each script separately in the VUgen just to make sure they run without any issues. Okay. Or in other words, they will debug the scripts and make sure there are no issues. Okay. 50 performance critical transactions. We create 50 scripts and we execute 50 scripts just to make sure these 50 scripts are working fine. Okay. Are we clear so far, Susie?
Yes.
Okay. Now the next step is we upload each of these 50 scripts one by one into the controller. Even though I have put only 3 over here, but you upload all the 50 scripts into the controller. Okay. Now the next thing what you do is you break down this 1000 users across all these groups. Okay. By the way, each one we call it as a group. Each one we call it as a group. Okay. So now this 1000 users, you break it down to all the 50 groups or all the 50 scripts. Okay. This 1000 users, you break it down into all the 50 users, 50 scripts. Okay. Which means that you add up all of this for all the 50 of them, it should come to 1000. It should come to 1000.
Okay. Is there any limit to create the script name or LG name
No.
in one time, or okay, there's no limit, right?
There is no limit, but the limit is there on the number of virtual users. Since they ask you to run it with 1000 users, you are supposed to run it with 1000 users. Okay.
Okay.
So if your LG machine can support all the 1000 users, for all the groups you can use LG1, 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 LG1. Okay. But if one LG machine is not supporting all the users, then you have to use multiple LGs like LG1, LG2, LG3 and all that. Are we clear?
Yes.
Okay. Now, once this all setup is run, this is what we call it as a test scenario. We call this what? Test scenario. We call this is what? Test scenario.
This is scenario.
Okay.
Okay.
So this is called as a test scenario. Now, your test scenario is done. You click on run button. Once you click on run button, all the scripts will be executed simultaneously. All the scripts will be executed simultaneously, and typically you run any test for what? 1 hour. You run any test for what? 1 hour. You run any test for 1 hour. Are we okay, Susie?
Yes, yes, I'm listening.
Okay, so now all the scripts will be executed simultaneously and they continue to execute for 1 hour. After 1 hour, you will get the results. After 1 hour, you get the results. After 1 hour, you get the results. After any execution, you will have the results. So here also, you will have the results also. Okay, after 1 hour, you get the results. Okay, so in the results, the first important thing that you look for is the response times. The most important thing that you look for is the response times. The most important thing that you look for is the response times. Okay. Now, as a part of NFR collection, you will collect something called SLAs as well. Okay, service level agreements. Let's see what all your service level agreements looks like. You said, the client said for simple transactions, the response time should be less than or equal to 2 seconds. Medium complexity, the response time should be less than or equal to 5 seconds. And very complex one, the response time should be less than or equal to 8 seconds. This is what the client has given as a part of NFRs or non-functional requirements. Now you have run the test, and you have the result.
I'm sorry, what was SLS stands for?
Service level agreements.
Okay.
Okay. So that is something that is received by you from the client. That is something that is received by you from the client. Okay. So now you have run the test. For your transactions, you have the response times as well. Okay. Client has given you some response times, what it should be, and you have got something. and then now you have to compare both of them. You have to compare both of them. You have to compare both of them. Let's see what it is. Okay. Let's say this is the response times that you have received for different transactions. Okay. This is the response times that you have received for different scripts. Okay. These are the results. You see, for login transaction, it is 1.2 seconds. For check summary transaction, let's say what you have received is 1.5 seconds. Back to home transaction, what you have received is 1.8 seconds. For logout, 0.5 seconds. Like this, for each transaction, you receive the response times. For each transaction, you receive the response times. And these are the SLAs that is given by the client. You see, 2 seconds for simple transactions, and for complex transactions, it is 5 seconds. And for more complex transactions, it is 8 seconds. I haven't included the example for 8 seconds. Okay. Now you compare this against this. You see, what you received is 1.2. What it is supposed to be 2 seconds. So what you received is less than the SLA. So this is good. So this is also less than SLA, which is good. So like this, you compare for all of them. And as long as it is less than SLA, you are in a good shape. As long as you are in less than SLA, you are in a good shape. Your test has passed. Otherwise, if your response times is more than SLA, then you have to send the code for bottleneck analysis. This is what a sample case study. Susie.
Okay.
Okay. So
always the response time captured has to be less the SLA number.
Yes, if it is less than SLA, then your application is fast. If it is more than SLA, then your application is slow.
Okay.
Okay. Who gives the SLA? The client gives the SLA. As part of what? NFR.
Mm-hmm.
Sounds good?
Okay. Yes.
Okay. So you gather the NFR, you create the scripts, you execute the scripts, you get the results. Compare the results against the SLA. Compare the results against the SLA. This is what you do in a performance testing.
Okay.
Okay.
Thank you. Can I ask another question?
Sure.
Do you mind?
Ask as many questions.
Sure. Would you please make it clear for me how to connect the LG? Remember, you were showing us how to connect the LG with platform, if I'm not mistaken.
Yes, yes. Okay. So this is the controller. Okay. Open the software called controller. Okay. Go to scenario. Okay. Go to load generators. Okay. First, let me delete this so that I can tell you how to add it.
Okay.
Why does it delete? Disconnect. Now I can delete. Okay. Hang on, guys, 1 second. Usually it should get deleted. Okay, so let it be there. The local host is there. Let it be there. See how to add it. Okay, so click on add, and your company folks will give you the name of the LG. Let's say the name of the LG that they have given is 3PC. Let's assume. Okay, now enter that, and they will also tell you what platform this is. Is it a Linux machine or a Windows machine? If it's a Windows machine, click on Windows machine. If it's a Linux machine,
okay.
Linux machine. Okay. Now you click on OK. Now that is added. Now that is added. Now once you click on connect, make sure it is ready. If it is ready, which means that your LG is ready to use. That's it. Okay. Sometimes it's down, which means that your LG is not properly connected. Then you can talk to the infrastructure team and see what is the problem. Okay. It is a very, very simple step.
Okay. All right, Kumar. Thank you so much.
Okay. Yeah. So wonderful, guys. Have a good day. Tomorrow I'll catch you at the same time. Okay. So
Sure.
and we'll catch up. Okay. Thank you so much. See you.
Thank you so much. Bye bye.
Bye bye. Take care.
You too.